Hi everyone, Emily here from the Youth Services Department at the Lynchburg Public Library. Thank you so much for joining us for our 6th session of Summer STEAM right here on our YouTube channel. Don't forget to check out our website at lynchburgpubliclibrary.org, as well as our Facebook page for a complete schedule of our virtual programs, as well as for information about our Read Squared summer reading program. Today's STEAM lesson is titled Myth or Fact because you're going to be doing 3 experiments that defy logic. Will they be possible or won't they? You'll have to do these 3 fun and simple experiments to find out. Before we get started, let's take a look at the list of materials you will need for today's STEAM experiments. For today's STEAM activities, you will need the following materials: a dime, a quarter, a pencil, a pair of scissors, 2 or more index cards. These can be either 3x5 or 4x6 index cards, lots of sharpened pencils, and these need to be number 2 pencils, not mechanical pencils, a large Ziploc bag, and water. For our first myth or fact experiment, you will need to grab 1 index card, your pencil, your scissors, your dime, and your quarter. This myth or fact experiment poses the question, can you fit a quarter through a dime-sized hole? Let's find out. All right, once you guys have gathered your materials, you are ready to get started with our first myth or fact STEAM experiment. To start, you're going to take your index card and fold it in half this way. Next, you're going to trace your dime and try to have this right in the center of the index card like this. Take your pencil and trace. And you should end up with a circle right in the center there, just the size of a dime. Now you're going to fold your index card back this way so you can see that outline, because you're going to cut out the shape in the center. All right, so you should end up, looks like I need to adjust my cutting a little bit there. You should end up with a dime-sized hole that the dime can easily fit into. But remember, the question we're asking is, can a quarter fit through a dime-sized hole? Not can a dime fit through it. We know that a dime can. So just looking at it, it doesn't necessarily seem like it's going to be possible, does it? Look at the size difference between the quarter and the dime. It's pretty substantial. And when we do just a quick test, the quarter stays on top of the index card and doesn't fall through the hole. So the question is it going to be possible to fit the quarter through the dime-sized hole? The only way to figure it out is to do the experiment. So before I show you guys how it might be possible, think of the ways that you would try to fit the quarter through the dime-sized hole without using your scissors and making that hole bigger. What do you think you could do to the index card to make it work? Go ahead and take a moment and think about how you would do the experiment. All right, are you ready to learn the trick? It turns out that this is not a myth. You can fit a quarter through a dime-sized hole. The key is to place the quarter right over top of the hole and fold your index card in half like this, And obviously it's not just going to slide right through, or it already would have done so. So you're going to have to do something to the index card to make the quarter fall through the hole. Any ideas? Okay, so here it comes. What you need to do is take the two sides right beside the quarter and push them inward, thus making this circular shape an ellipse. And we'll define an ellipse and what elliptical means in just a moment. But go ahead and see if you can get the quarter through the dime-sized hole by pinching the sides. There you go. It worked. So all you have to do is put the quarter in the center, pinch the sides, and it comes right through the dime-sized hole. And you may have to do a little bit of pushing. It depends on how thick your index card is, but it should work. And there might even be like a small tear in there, and that's okay. As long as you don't cut the hole to make it bigger, the quarter may force a little bit of a tear in your index card. But the important thing is that we were able to transform the circle shape into an elliptical shape, or more of an oval shape, and that allowed the quarter to fit through. So before we move on to the next experiment, which also is going to use an index card, let's go ahead and define a couple of key concepts for this experiment, which are ellipses and elliptical, and diameter. Let's take a look at those definitions now. Diameter is a straight line passing from side to side through the center of a body or figure, especially a circle or sphere. A quarter is a larger coin and has a larger diameter than a dime. That's why the quarter is unable to fit through the dime-sized circle when the card is flat. Elliptical is the shape of an ellipse, which is an elongated circle stretched into an oval. When the card is folded in half and is bent just slightly, the circle in the center changes and becomes elliptical. That means that the opening becomes wider, allowing the quarter to slip through. All right, guys, are you ready for our second myth or fact STEAM experiment? So for this challenge, you're going to see if you can fit your body through an index card. How is that even possible, you might wonder? Well, you're about to find out by doing this experiment. You only need 3 materials for this activity: scissors, an index card, and a pencil. The first step is to fold your index card in half this way. Then, on the folded edge, not this end that has the open sides, but on the folded edge, you're going to make a tick mark about 1 centimeter in from either end of the index card. You can use a ruler for this if you want. I'm just going to eyeball it. It doesn't make a huge amount of difference anyway, but you do want to have just a small spacing, and you'll see what I mean in a second. So I'm just eyeballing 1 centimeter here on either side. Again, you can use a ruler if you would like. And now what I'm going to do is make 2 cuts using these as my guides. And what you want to do, again, this is on the folded edge, is take your scissors and cut, but you're not going to cut all the way down and remove this strip. So you are going to be cutting through 2 layers, but you don't want to cut all the way down. You want to cut almost to the edge right here. Okay, so do it on one side. Get pretty close, but not all the way, and then do the same thing down here, still cutting on the folded edge. All right, and then once you do that, you're going to open up the index card, and you're going to cut down the center crease, but be sure to not cut through the edges right here. So you're just going to cut in between the 2 slits. So make a cut right down the middle. And and you'll end up with something that almost looks like an opening door. It's kind of a cool looking shape. Okay, so then you're going to fold your shape down the middle again. Now what you're going to do is you're going to be making some more cuts that go almost to the edge but not all the way, because we need our index card to stay enclosed. We want it to be an enclosed shape that we can fit through, potentially. We don't know yet. But in order to do this, what you're going to need to do is cut from alternating sides of the index card. And you're going to want about that 1 centimeter length between your cuts. But it is imperative that you cut on alternating sides, okay? So the first cuts I made on the folded edge, here and here. So the next cut I need to make, let's say I start on this end, is I need to cut from this end and go almost all the way to the edge, but not quite, okay? And then you're gonna alternate. So you're gonna cut from here and go almost all the way to the edge, but not quite. And you're gonna do that all the way down your index card. So you are gonna have to eyeball. It's a little bit of an inexact science. You're gonna need to eyeball as you get closer to this end, how large to make your cuts or how far away to make your cuts to make sure that it stays alternating, if that makes sense, okay? So I'm not gonna bore you with making you watch me cut this entire thing, but I will speed up the video of me making those cuts, and then we can look at the product of that. All right, so let's go ahead and make those cuts, and just be sure to alternate and not cut all the way down, or the index card is going to fall apart on you. Here we go. All right, guys, thanks for bearing with me through that. So did you make all of your cuts? You should have a very interesting shape that looks kind of like this, but we aren't going to know until you open up your index card if you made all of your cuts correctly. And remember, it's okay if you didn't. I did this experiment earlier and accidentally cut all the way through, so I had to start over. But that's part of the fun of STEAM. You just get to keep on trying, keep on trucking, and have fun with it, okay? So let's open up our index card and see what we've got. Whoa, look at that, guys. That is super cool. Do you guys have something like this? It makes this really cool kind of open ring shape, but it's got little, almost like Hershey Kiss looking little peaks and valleys in it. I don't know how else to describe it, but isn't that kind of a neat little shape? That used to be a rectangular index card. Isn't that wild? And again, if you guys are using a 3x5 index card, it's going to be a little smaller than this, but you should still be able to step through it. A fun variable to do for your experiment would be to try with a 3x5 and a 4x6. I happen to have a 4x6, but either way, you should end up with a shape kind of like this. It's enclosed, and if you can step through it, remember, you're still stepping through an index card. Isn't that crazy? All right, so now it's time to test and see if we can step through. So let's go ahead and get ready to test our index cards. All right, friends, I've got my index card here. So now it is time to test and see if I can step through it. So if you've done the experiment as well, go ahead and see if you can fit through your index card, all right? Moment of truth, here we go. And you can start either with your feet or your head. Feet, probably gonna be a little bit easier, but it's totally up to you. All right, here we go. Let's test it out. This is a little bit more difficult in the dress. This part is a little tricky too, but whoa! So there you have it, guys. I was able to step through my index card. How about you guys? Were you able to fit through yours? We would love to see photos of your experiment and see how it went. So be sure to tag us in your photos on Facebook or send us a Facebook message. Just send it to the Lynchburg Public Library through Facebook Messenger. So how did it go, guys? Did you fit through? All right, let's go on to our third and final experiment. Good job. Before we move on to the final experiment, let's talk about surface area and how it helps explain the experiment you just did. Surface area is a measure of the total area that the surface of an object occupies. Although an index card seems small, the surface area of a 3 by 5 inch index card is 15 square inches. The surface area of a 4 by 6 inch index card is 24 square inches. By carefully cutting the index card in the pattern you just used, you are redistributing the entire surface area across the length of the ring, all while keeping the surface area connected. The closer together you make your cuts, the longer the ring will be. The surface area of the card never changes, so the width of the ring directly impacts the length. Our third and final myth or fact experiment involves puncturing a Ziploc bag filled with water using sharpened pencils. Do you think it's possible to do so without spilling any water? Let's do the experiment and find out. All right, friends, it's time for our third and final myth or fact STEAM experiment. And this one is probably the most exciting and logic-defying of them all. So what you're going to do for this experiment is take a large Ziploc bag, about half full of water. Mine is more 3/4 full, but at least half full of water. Doesn't matter what the water temperature is. And you're going to use sharpened pencils. I have 10. Feel free to try fewer or more than that, totally up to you. But you're going to be actually spearing your Ziploc bag with your sharpened pencils. Now, it's very important before you start, be sure that you're either doing this over a large container like the one I have here, or over the sink, and you probably want parent or guardian supervision for this project because it does involve sharp pencils, and the pencils do need to be sharpened to a point for this experiment, and they do need to be number 2 pencils and not mechanical pencils. But anyway, go ahead and fill up your large Ziploc bag. Make sure that the bag does not have holes in it already. You probably want to use a new Ziploc bag and not one that you're reusing. And make sure it's sealed at the top. And again, be sure that you've got a large container or that you're doing this over the sink. And then you just go for it. So I'm going to go ahead and start with my first pencil. As you can see, it's quite sharp. And you want to just kind of go ahead and jab it in there. Again, be super careful. I would do it either like hold out the bag away from you or have a parent help you, older sibling. Just be sure you're doing this safely. And this is scary. I have to tell you, I've done this so many times, but every time I'm like, oh my goodness, the water's going to come out. But it shouldn't. So spoiler alert, this myth or fact experiment, it is a fact that you can spear a pencil or pencils through a Ziploc bag full of water and have water not spill out. And we'll talk about the science behind that in a minute. But first, let's get going. Here we go. 1, 2, 3. Whoa! Check it out, guys. How did yours go? Did your first pencil go through and not create a spill? Isn't that wild? Oh my goodness! It surprises me every time I do it. It's so cool. All right, so we'll talk about why it was able to go through in a moment, but first, let's try some more pencils. I will say, be sure that you don't push the pencil all the way through or you are going to end up with a mess, okay? So let's just try a few more. Wow, it worked again. This is so fun. Are you guys having fun? Let's just keep going.
Whoa, and not a single drop in my container. All right, I'll do a couple more. As you can see, I didn't even do that one quite as fast, but it still worked. So experiment with the different speeds of putting the pencils in. You definitely want to do it with purpose and don't waver, but you can still do it kind of more slowly than you might think you need to, and it's still not going to create a leak. Okay, but once you pick a spot, you have to commit to it. All right, so keep going. I don't know how many pencils you guys are using, but keep trying. You can try things, your pencils at different angles, whatever you'd like to do with that. But hopefully you will end up with a Ziploc bag with pencils through it and no mess. All right, have fun with this, guys. And let's go ahead and talk about the science of how this works.
To understand the science behind this experiment, we first need to define polymer. A polymer is a substance that has a molecular structure consisting chiefly or entirely of a large number of similar units bonded together. The Ziploc bag you used was most likely made out of a polymer called low-density polyethylene. It's one of the most widely used packaging materials in the world. It's low in cost, lightweight, durable, a barrier to moisture, and it's very flexible. Think of the polyethylene molecules as long strands of freshly cooked spaghetti. The tip of the sharpened pencil can easily slip between and push apart the flexible strands of spaghetti, but the strands' flexible property helps to form a temporary seal against the edge of the pencil. When the pencil is removed, the hole in the plastic bag remains because the polyethylene molecules were pushed aside permanently and the water leaks out. I hope that you enjoyed today's logic-defying STEAM experiments. Thank you again so much for joining us. Just a reminder, we have 2 more sessions of summer STEAM, and those will be released the next 2 Thursdays at 10:30 a.m. right here on our YouTube channel. Until then, please stay tuned to our Facebook page and website for more information about our programs and to learn more about our Read Squared summer reading program. We miss you guys, take care, and we'll see you again soon. Bye!